All right, guys. Good morning. Happy Sunday. Welcome back. We are still on our CCNA journey. We are back on chapter 9, spanning tree protocol concepts. And we're just getting through the fundamentals of spanning tree. Um, I know I promised you guys a lab today, and we will do that. I just needed to cover one more thing before we have a lab. Okay. Um, I know you see my screen and you see the port call. So we will talk about that in a second. What this is associated with seeing the port calls associated with the Ethernet speed, is configuring the influence of your spanning tree topology, right? So by default, right, Cisco has their settings for each technology: OSPF, um, BPD, BGP, and so on, right? Um, if we're talking about spanning tree, right? Switches have a default bridge ID, right? Based on their, default priority value, right? And of course, you have that MAC address that's uniquely assigned to that device, right? We spoke about those things in the last section. Um, but right, and you guys learned about root costs or what have you in interfaces, right? But one thing switches have, right? Switch interfaces have default spanning tree costs, right? Based on their operating speed, right? Okay, right? So if we wanted to go ahead and influence, right, how we want or change how we want our, spanning tree to operate, we would then change those settings in regards to the cost, right? And we can do that, right? And so the two tools that we can use to influence our spanning tree topology is one, the bridge ID, and two, changing the spanning tree port cost. Okay. We went over, in the last two videos, how to, of course, change the bridge ID, right? We can't change the MAC address. And let me make sure I'm clear. We can't change the MAC address. We never can. We always can change the priority value. Okay. That will change the entire bridge ID. Okay. All right. But we can change the port cost. Okay. We could change it per port and per VLAN. Okay. All right. So let's go over, right, what this table means, right? So what is this? Table 9.6, right? So before, 1998 and before, it lists, right, just regular spanning tree, right? The port cost of just how it works if we're just using spanning tree, right? 10 megabits, 100, right? The cost is 100, right? 100 megabits, the cost is 19. 1 gigabit, right? It's 4. 10 gigabit, it's 2. And 100 gigabits and 1 terabyte, they don't have a cost, right? Well, that doesn't work, right? What we can do, right, is we can go ahead and configure the switch to go ahead and use new defaults, right? New defaults according to IEEE clause 2004 and up, right? Um, we have been graced to go ahead and have access to faster speeds. Okay, so now, right, if we have 1 gigabit, right, it's 20K, right? 10 gigabit, 2K, 100 gigabit, 200, and 1 terabyte, 20, right? Why do we need that, right? Now we have data center speeds that equal up to those higher speeds. If we had, right, if we were, using port costs according to spanning tree 1998 and before, right? Anything above, you know, 10 gigs would all be looked at as the same. And I'm sure you guys can think about things that we've talked about before, how they can cause an issue in our environment. Okay. So this is a key topic, right, for your exam, because of course, this is something that you need to be able to do on paper, right? Whenever you're reading some of these topologies that pop up and be able to choose the right answer, right? A lot of spanning tree questions may pop up has multiple, right? Multiple answers. So please um, be able to memorize this table, right? And do a lot of practice on paper. Okay. Now, with that being said, let's go ahead and make a lab. Okay. Let's call this span tree. Save it. Okay. All right. And we're going to go ahead and add 3 switches, right? Okay. Let's do that. Da, 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 da. Whoops. That's not the one I wanted. Let's look for our switches. There we go. Okay. And let's pull this bad boy. There we go. And let's do 3. Excellent. All right. Let's create a topology. We'll put, well, you know what? Let's do the topology that we're typically used to in our book examples. Okay. Let's make that. All right. So let's connect that. Excellent. And let's do that. Let's do that. All right, let's bring that a little bit down. Let's make it look pretty. Let's connect that. Cool. Let's connect that. Awesome. All right, let's do that. Now, what we're going to do is we're going to go ahead and turn on this switch first. We need to prove a few things, right? A couple of things is we are going to look at the verification command for spanning tree. We're also going to see what we want to prove is what frames are coming out of the switch. Okay, right? I want us to see what that frames looks like. All right, so we can go ahead and fully dissect it. Let's let the switch boot up. All right. Okay, looks like it should be ready. Okay, there we go. Okay, excellent. All right, so the switch is now started. Once it goes through all of its syslogs, I'll tell you one thing, I might pull out my physical lab for you guys moving forward so it can make sense. Okay. All right, I'll get through all its interfaces. There we go. Should be done now. All right, there we go. All right, let's clean up this terminal. There we go. All right, so first things first, let's clean that out. And let's look at what our spanning tree looks like. Okay, all right. So let's take a look at this verification command, right? It's only telling us right? The instance, okay, I want you guys to get used to that word. The instance for VLAN 1, okay? All right. And it tells us we are using the default, right? The old school version of spanning tree. So just STP, whenever you see IEEE, that's how we know we're using just regular spanning tree, right? And of course, as it was explained in the book via theory, we have root ID and bridge ID, right? Within the root ID, as you guys can assume, it's going to show us all the details of the root, right? So we have the priority, right? 32,769. Okay. The priority is typically, let me get my notepad. The priority is typically made up of the number 32, 7, oops, 768 plus the VLAN number. Okay. So you guys can see 3276, right? 68 plus the number 1 for VLAN 1 gives us a priority if we left the values default, 32,769. Okay. All right. The address of the root bridge, right, is 5000.0001.0000. And then we have this message, this bridge is the root, right? This means this switch is the root switch, okay? We also have our timers. We have a hello timer, which is 2 seconds. We have a max age timer, which is 20 seconds, and a forward delay, which is 15 seconds. We will go over timers later in this chapter, okay? Um, and of course, we have our bridge ID. Now, this bridge ID identifies who we are, right? This instance, right? What this device is, okay? We have set a priority, okay? As I showed you guys, right? The priority is, of course, the default number plus that VLAN, right? System ID extension, which of course, AKA the VLAN, is 1, okay? The address of our bridge ID is this, okay? Now, this looks familiar, right? We see this right here, right? Whenever you're looking at the show spanning tree, you want to slow down and note take a couple of things. Okay. So we notated that the root bridge ID and the bridge ID is the same. So we can assume this switch is the root. Okay. All right. So one thing that we went over in theory is that I told you guys that every switch will assume it is the best option for the spanning tree topology to become the root. Okay? All right. And of course, since it does, right? Since it did make the declaration that it is the best option for the spanning tree, since it's not connected to any switches that are turned on, right? It assumes the role for its ports to be designated, right? And of course, you guys learned for a root switch, all of its ports is going to be in a designating role, and the state is going to be in forwarding. Okay. Now, you guys just learned about port costs. Okay. So, with that being said, you guys can see that this switch's port cost is according to the IEEE costs before 1998 and before. Okay. So we're going to upgrade this, but for now, we're going to keep it simple. Okay. All right. So just for this, let's go ahead and add some text in. Okay. Port cost 4. Okay. Duplicate that. Boom. So we have a port cost of 4. Let's make sure we identify that. Okay. Excellent. All right. So we have all that. We have our connections. Okay. Now, let's see if we can see some traffic leaving our switch. right? Or leaving that interface. Okay. Okay. All right. Hopefully it works the first time. Okay. And what I'm looking for is spanning tree. All right. Let's break this down. Okay. Okay. So what do we see here? Right. First things first, we see IEEE 802.3, right? Standard for Ethernet. Of course, there's always going to be within the header of layer two, which you guys learned before, a source and a destination. We have our source, which is this switch. Okay. All right. And our destination, okay, is a multicast address, right? And this multicast address, right? You guys will learn about multicast in the future. Okay. The concept of multicast, I think you guys learned it briefly, right? Briefly in chapters two or three, something like that. Multicast, how it works. It works similar to broadcast, but for you to receive multicast frames, you have to be a part of the multicast listening group. Okay. All right. So what Cisco did, and of course the IEEE did, right? Certain multicast addresses, right? If you implement certain technologies are automatically assigned to a multicast group to be able to listen to these frames or packets, whether it be layer two or layer three, to listen to these, you know, packets or frames coming into the switch, right? So the control plane can effectively operate, right, in totality, right? So I need to be always, if I'm a switch, I need to always be listening to that spanning tree multicast address, right? So I can always receive BPDUs, no matter the cost, right? No matter if something's going on, if the CPU's messing up, I need to always be listening for spanning tree frames. Okay. So, and this is going to be for all, right? Going to be for all switches. All right. So that's a little bit example for multicast, right? Let's look at this. Like this is what we really want to break down. Let me zoom in a little bit. All right. Let's break this down. Right. We know, of course, it's spanning tree. We're using, of course, regular spanning tree. We got the protocol identifier. Ah, this is what we're looking for. We have our BPDU type, right? And it's a configuration BPDU, right? Let's look at the flags, right? We haven't gone over topology change or topology change acknowledgement. We will go over that soon. Let's go over this, right? What we see in the switch whenever we do our verification command. We have our root bridge ID, right? A root identifier, right? We got that priority, 32768. We have that root bridge system ID extension, right? This is the VLAN. This is one, right? So there's different BPDUs for different VLANs, right? So we may be looking at, right, in a different situation, we may be looking at this for VLAN one, but there will be a different BPDU for different VLANs, okay? And of course, this is the root bridge ID, right? The same thing that you see within the spanning tree verification command, you get to see within Wireshark, okay? Let's close this. One of the most important things that you guys learned in this chapter is the root path cost. Okay. Okay. What is the cost, right? What is that root path cost to the root, right? Remember, you guys learned about this when we were learning about the election process for choosing the designated switch. Okay. And of course, we have the bridge ID. Okay. All right. We have the port identifier, right? Every port is indexed, right? So that number that we see, maybe gigabit 0/1, 0/2. There is an index number that you may not have access to, right? Unless you are, the vendor's technical assistance center engineer. Okay. So don't worry about that so much. Okay. Um, we have message age, max age. hello time, and forward delay. We will talk about that soon. Okay. So let's close this up. All right. So, like I told you guys, even though we're not receiving anything, our switch will always, right, be on the ready and forwarding those BPDU frames out of its ports, even though it's not connected to a switch that may be on in an on state. Okay. And it's always listening, right? Listening to that spanning tree multicast address to make sure it is ready to receive BPDU. Okay. All right. So let's go ahead and let's turn on switch two. Okay. Let's do the same thing with switch three. Let's go ahead and start up our topology. All right. So while we're waiting, everybody unmute and let's go ahead. Any questions you guys have about the port costs, about anything that we've seen?
No, I kind of like I created a lab just to follow along with what you was doing and look at everything you was explaining.
Okay, good stuff. Good stuff. Okay.
I can't think of any questions right now. I'm sure I have some.
Sure. No
Yeah,
problem
same
at
for
all.
me. I'm just taking notes. I probably when I read my notes over, I'll have questions.
Nah, no problem.
I would like to actually ask you to reiterate the MAC address that the VLAN has. Is that the one that actually gets defined when we have a bridge ID plus a MAC address?
I'm sorry, say your question again.
So for example, like the root bridge right now is the switch one. And we have a MAC address there listed under the VLAN. So does the VLAN itself create its own MAC address, or is it the MAC address out of any of those interfaces like G01 or G00
I see your
of the
question.
switch? Yeah.
I see your question. So remember, by default, in computing in general, you cannot change the MAC address.
Yes.
Okay. That's just fundamentals. This is never going to change, and you can't change this unless you are using first hop redundancy protocol or some other technology, right? Where you're using a virtual MAC address. But in this case, you are not changing it. Okay. This is the second part of the bridge ID. The first part of the bridge ID is your priority. This is what you can change to influence the spanning tree. Okay. You can change this. Okay. Does that make sense?
Yes, but where does the MAC address comes from here?
That is the system MAC address.
Okay.
This is what comes burned in from the factory.
No, the interface, just basically the whole switch's MAC address. Am I right?
Yep, the system MAC address. Each interface has a MAC address, and it'll be right. What the difference will be, and I think you're asking, will be in the last octet, right,
Okay.
for each interface. But the system MAC address is going to be this.
Okay. Okay. Perfect. I'm good with that. Thank you.
Make sense?
Yeah, it does.
Cool. All right. All right. So let's check switch two. Let's see if it's ready. All right. Open it up. Okay. Awesome. All right. So let's check its spanning tree. Okay. All right. So let's pick on DeMarco. So we're looking at switch 2, right? Using our spanning tree verification command. And you know what? Let me clean this up. What do we see here?
So using that,
I want you to identify 3 unique things.
So we're looking at the root ID, which is 32769. The MAC address, which
MAC address for what?
The MAC address for the designated because that's not the root switch. So that's the designated switch. But that's the MAC address of the switch that we on. No, that's the MAC address of the. That's not the MAC. The bridge will be the MAC address of the switch that you're on currently on.
Slow down. We need to be engineers. So use this and this to tell me what you mean, because you just saying MAC address. There's two fields. Okay.
Gotcha. So the MAC address that's under the root ID is the is not the switch, then is not the current switch that you're on. The MAC address under the bridge ID is the current switch that you're on.
Good. Good. Okay, that's one interesting thing. Good stuff. Keep going.
And I know the hello timers. What the cost? The cost is for.
Cost is for what?
The cost is for the. It's for the root and the designated forwarding.
What do you mean?
So that's the path cost for the traffic to traverse over the link.
That doesn't make sense. What do you mean?
What the path cost for?
Mm-hmm. In relation to what?
In relation to the traffic traversing over the link.
We're not talking about traffic. We're talking about verifying spanning tree just for this switch.
Thing it's right there. I'm I know
Sure.
what it is.
Hey, hold on. Donovan, you want to help him out?
I'm trying to think of the name too of the costs.
Anything interesting on this verification command?
Oh,
Okay. Anything. He already said one. I just need
okay.
two more.
Two more. mm,
let me see.
Markivia?
So switch to the switch to bridge ID priority is 3276.9, and then the switch to MAC address is the the 500.00002.
Mm-hmm.
And what else is interesting? I guess is it maybe the hello time on
I
switch
think
to?
Nope, we haven't gone over that.
Oh,
I think I
oh.
see it. The
the
3276.
default spreading tree. Well, no, I guess we know that.
Gary, you want to help them out?
Yeah, I can try. Based off the show spanning tree command, we basically looking at the most important informations here. To me, like we are looking at the root ID as well as the bridge ID. Those are the two different informations. The root ID is basically is the ID or the information from the root bridge itself. So for example, like the switch one's information will be displayed there. So pretty much the priority and the MAC address and the cost and so on. So whereas we have a bridge ID, which is the switch that we are on. So switch two, that's the information we're seeing there. So that's a two piece of the information. Moving forward, we see the interfaces itself that has a different roles, statuses, and costs set to it based off whatever spanning tree has picked up. Is there anything particular like that's how I understand this? We are not like to me, what I will say We are not on the bridge root bridge. We are basically on a different switch than the root bridge.
Okay. So
yeah.
guys, let me help you out.
Okay.
Right. All right. Keep it simple. All right. We have our root port. Gigabit 0/0. So can't we identify for our diagram what the root port is on switch 2?
0/0. Oh, yeah, that's the root port.
That's the last interesting thing. Markevia said the second one, which of course is the priority and the system ID. This is the last one. Okay. For the exam, I need you guys to keep it simple. Okay. So we identified our root port. Okay. Got our port costs. And let's make sure we build this out. Okay. Well, let's do that. Let's switch this to designated port. Let's make 2 of these and let's build out our topology. Okay. Excellent. Right.
David, can you go back to the CLI real quick on switch 2?
Sure.
Okay.
Now, with that being said, Markevia, what else? Right? What can we identify for gigabit Ethernet 0/1?
Gigabit Ethernet /1 is a designated port and the cost is 4.
Okay. Do we have any blocking ports on switch 2?
No,
Mhm.
So
they're all
what
designated.
so what can we assume about switch 2 in regards to our spanning tree topology? What is the switch's role? If it's not the root bridge,
It's just forwarding,
Forwarding traffic, right?
I
And
nope,
guess.
forwarding it? Oh.
nope.
Oh,
If we have our root switch, what is the other type of switch within a spanning tree topology that you guys learned about? Designated switch, right?
oh. So it's a designated switch?
Absolutely. Okay. So with a designated switch, right, we learn, right, that all of its other ports is going to be in a what state?
Forwarding.
Designated role, right, for each port. And the state is going to be in a forwarding state, correct?
Yeah.
Okay. Let's do that. Okay. Let's open up switch 3. All right, Don. Let's break down. Let's break down this one, Don.
Okay.
Okay. Tell me 3. I only want Don to do this, guys. Don, I want you to tell me 3 interesting things about this command output.
Okay, so we're looking at the third switch because of the bridge ID. The address is 3, is the third switch.
Okay. Well, not because it's the third switch.
Well,
This is always telling you what? That this is the bridge ID. This is the switch's identifications,
yeah.
right? Okay. All right. Keep going.
And the cost is set to 4. we're on port 1 gigabit. The
So
port is 1.
let me tell you a nugget. Okay. For on all non-root switches, this verification command, it's always going to tell you what the root port is.
Wrong.
If you look right there,
Mhm.
it's always going to keep it simple for you. It's going to tell you the cost associated with it. Okay. Little nugget for your exam. Okay. If you get put into the simulation. All right, Don, two more things. Tell me. It could be anything.
That is the designated port in the set. We got a designated switch.
What is the designated port?
Um,
I mean, you're right. You have designated ports here.
yeah. Uh, I mean, I can't say all those. Mm, I guess that's the root port, though. That's not.
There we go. That's one interesting thing for this topology. So we identified our root port is gigabit 0/0. So this is our root port. Excellent. Let's keep talking about our topology. What else do you see?
Mm,
You're almost there, Don. It's in the same area.
and the I don't know what I don't know what the ALT. I can't remember what it means.
Okay, I don't think we did touch on it briefly. So the role ALTN, it's abbreviated, it stands for alternate.
Okay.
Okay. And the state is in a blocking state. Okay. Right. So for your spanning tree topology, right? That is your last piece that you need, right? To build spanning tree topology. Okay. Because, right, the goal with spanning tree is we want one path, right? We want one path. We don't want multiple paths because that's where we have that loop and that broadcast storm. Okay. So
Can
what
you
we
bring that
do,
back up for me? I want to get a screenshot of that.
sure, I got you. 1 second. Let me clear that, clear that. Stop. There you go. Okay,
Okay, thank you.
no problem. All right.
Hey, Dave. Let me ask you. So for the alternate blocking port, is it that's just something they added just because I know it would have been blocking, but alternate is
Mhm.
something they added and it means kind of the same thing, right?
That's a good question. All right. So think about this. What happens if this happens? Let's go past it. What if this connection gets cut to the root?
And that
Don't
connect opens up.
don't we need an alternate connection?
Yeah,
There you go.
gotcha,
That's your alternate link.
gotcha.
Make sense?
Yep.
I'm simplifying it, but just to stay on track, that's your alternate link to your root. Okay. Let me turn this off. Excellent. So we have our spanning tree built. So if we go back to switch 1, show spanning tree, I can type this one. Okay, all right. And if we do a show, oh yeah, I'm not running it. All right. Let's do this for T, just so I can make sure it's LDP allows me to do that. And we'll keep this same lab. Okay, let's go. Now, let's do this. So, okay, of course, we got to put a name on it. Shame on me. Let's do host name switch. Switch to, there we go. And let's do, let's, all right, boom. And let's do switch 1, switch 3. Let's put a host name. Let's do switch 3. Yeah, switch 3. Awesome. Okay. What I want you guys to do, right? And I want you guys to practice, right? Because we have verification commands for a reason, right? Of course, to help us troubleshoot, but also to be able to get a sense of our topology. Okay. Sometimes you are not going to have the diagram in front of you of your network. You got to be able to build out your network using your verification commands, right? Worst case scenario, you only have one switch, okay, to go ahead and build out your network, right? So this is what we have, right? If we did a show LLDP, oh, let me get that drawing off of there. If I didn't have a diagram, right, this is what I'm doing, right? I'm looking at this. Let's assume that LLDP or CDP is enabled, right? This is what I'm doing. Okay. Okay, gigabit 0/0, gigabit 0/1, right? I'm looking at that and I said, oh, excellent, right? That this is hanging off my local interface, gigabit 0/0, right? That's my connection to switch 2. Gigabit 0/1, right? That's my connection to switch 3. And they're connected to me by their gigabit 0/0. Now here's where spanning tree comes in. It's going to give me a sense of what's your topology look like, right? And I know, okay, excellent. It's using old school spanning tree. Okay. I see the port cost being 4. Priority of the root, right, is the default value, right? And of course, I see the MAC address and it's telling me this bridge is the root. It's telling you clear as day, this bridge is the root. No need to think anymore, okay? We have our hello timers, right? This comes in handy in terms of troubleshooting, right? If we're having errors and stuff like that. But we will learn, you guys will learn about the timers in the future, okay? I have my bridge ID, okay? Able to see all this, okay? Right? And I see all of my ports are in a designated role, right? And it's all in forwarding. You guys, right? And let's critically think here, right? If all my ports are in a forwarding state, right? And all the roles are designated, excellent. This is the root switch for my topology. Let's log in to switch 2. Now, of course, if I had IP addresses on my switch, right, I'll be able to find out the IP addresses and, of course, log into those, right? Assuming that I have the, assuming that I have the, assuming that I have the password for them, right? Then I have that. I can go ahead and start building a picture of my network. Okay. Then let's say I can go ahead and get into this switch, right? I get into this switch that I don't know about. I do the same thing, right? You are an investigator, okay? You are the engineer. You have to know about your network, okay? Same thing, right? Okay, LLDP is telling me, okay, I'm connected to switch 3 off of gigabit 0/1 on my local interface. I'm connected to switch 1 gigabit 0/0 off my local interface, right? You guys can paint it. You guys can draw a picture now. You can literally get a pen and a piece of paper and draw a picture now. I can see where I'm connected at on switch 3. Okay, how switch 3 is connected to me via the port ID, right? I can see how switch 1 is connected to me via the port ID. If I do a show spanning tree, I can see, oh, that last switch I was on is the root, and switch 2 says it, so it's definitely connected, right? Right? And I'm connected to it using what? Gigabit 0/0. That's my root port. Boom. We're verifying here. Let's do our other verification. If I look down here, excellent. That's my root port. Guys, there's a method to the madness of you guys learning all of this. Please lab up. Please learn all these things. It is going to help you for the exam. Once you learn all these things and you make it muscle memory, the exam will be a piece of cake. And you probably can finish it in 45 minutes. Okay? All right. We'll go ahead and stop here. And you guys have a great day.
All right, thanks, Dave.
Alrighty, thanks,
All right,
Dave.
thanks,
Thanks,
David.
Dave.
Bye,
Bye.
Bye, guys.
guys.